This is the first of two videos in which I will demonstrate the process of solving quadratic equations by using what's called the completing the square method. And if you are familiar with my handwriting, or more specifically, handwriting in my math videos, you will understand full well why we're going to use GeoGebra to show all the work. Now up here I'm going to list off the step that's required, but because this is a math video, I will provide you great and insightful commentary like the following. If I'm supposed to divide all terms by the coefficient of a, and I happen to see that a has to be 1 because there's no coefficient actually being shown to x squared and yet x squared arrives, then I will need to divide all the terms by 1. And when I simplify, I get exactly the same equation. Okay, so maybe that wasn't so helpful for there, but we'll move on to the next step, which is very much needed. And that is, we need to move the constant, which in this case, -7, to the right side. And we'll do that by actually adding 7 here and adding 7 here to come up with the equation x squared minus 6x equals 7. It's very important that you leave the quadratic term and the linear term alone in your new equation, which isn't new because we didn't really do anything yet, and leave yourself an opportunity to add your own constant. So how do you get that constant? What you need to do is take the b over a, first computed up here, and simplified as -6. And what we need to do is now divide that number by 2, and you'll come up with -3. We're going to use -3, but we're not going to do it right now up here in this work. It's going to come a little later. What we are going to do is take that -3 and square it. It is the 9 that we need to immediately use by adding it to both sides of the equation. Now on the left side you have x squared minus 6x plus 9. By choosing 9, you have just made this a perfect square trinomial. And a perfect square trinomial has two factors that are identical to each other, which means you can write it as a quantity squared. And that is why it's called completing the square. So if we actually do write its factors, please note that the -3 that you came up with here is actually going to be used in that quantity. So all you have to remember is go quantity of x and then whatever result is. If it's a +3, you go +3. But in this case, it's -3 and you write x minus 3 quantity squared. So you have a quantity squared, which you can now take the square root of both sides. Remember that when you take a square root of an expression that involves a variable, you need to make sure you guaranteed it's a principal root. You will need to use absolute values around the x minus 3. Now the principal root of 16 is just 4. What happens is by removing the absolute value, you can now rewrite the right side as plus or minus 4. So if you want to solve this equation, add 3 to both sides, and you get x equals 3 plus or minus 4. In this case, x will equal 3 plus 4, which is 7, or x will equal 3 minus 4, which equals -1. Now let's look at 2x squared plus 8x plus 3 equals 7. You may recall that our first step is to actually divide all the terms by a, which in this case is 2. So the quadratic term, linear term, constant term, and value all get divided by 2 and simplify down to x squared plus 4x plus 3/2 equal to 7/2. We need to move the constant 3/2 over to the other side. So by subtracting 3/2 from here and from 7/2, we will come up with 4/2 on the right side, and thankfully GeoGebra has already simplified that to 2. Now it's time to find our magic term that will complete the square. But to do that, we'll take our 8 divided by 2, which is 4, and we'll divide that number by 2, and we'll come up with 2. But we'll take that 2, and we will square it, and we'll come back with 4. This is the 4 that needs to be added to both this side and this side, just like I'm doing right here. You've now got your perfect square trinomial. We can factor it very quickly by remembering that this 2, a positive 2, will be part of the factor that's being squared. You will notice now I have it equal to 6. Even though I am square rooting both sides, I know that square root of 6 is going to be an irrational number. That's okay. We still go through the process, remembering to use our absolute value. We'll make it equal to square root of 6. Remove the absolute value by rewriting the right side as plus or minus radical 6. And it's very simple. We will subtract 2 from both sides and coming up with the equation x equals -2 plus or minus radical 6. If you want to get approximate values, that's fine. But remember, the top part is an exact answer. And it just tells us we have 2 irrational values. For this last example in this video, we will take x squared plus 7x minus 1 and make it equal to negative 3. Our first step is to find the coefficient of a, which is 1, divide it into all the terms, and come up with exactly the same equation as we started with. So let's get right to the key parts. Let's add 1 to both sides of the equation, so we rewrite it as x squared plus 7x equal to negative 2. Now we need to take that 7. We have to divide it by 2. This is where some students would like to use decimals. I'm not a big fan of it. You're more than welcome to do so, but I think students understand it better if they leave it as fractions. So yes, when you square 7/2, you are going to come up with 49/4. And I would recommend adding 49/4 to both sides. You now have that perfect square trinomial x squared plus 7x plus 49/4 on the left side. You have negative 2 plus 49/4 on the right side. You're going to take that perfect square trinomial and quickly factor it, remembering it's x plus whatever you got when you did b divided by 2a, which in this case is plus 7/2. That factor is squared. You'll use your brain, you'll use your calculator, I'll use GeoGebra, and figure out that the right side equals 41/4. We'll square root both sides. We'll write the absolute value of the left side, and having the right side equal to the square root of 41, and simplifying the denominator as 2. When we remove the absolute value and we subtract 7/2 from both sides, we will get x equal negative 7/2 plus or minus radical 41/2. And if you choose to rewrite it, you could write negative 7 plus or minus radical 41 all on top as a numerator, divided by 2 as a denominator. And if that sounds something like you might see in quadratic formulas, there's a reason for that.